In this video, we're going to be looking at infinite geometric series and some summation notation that you can use for both arithmetic and geometric series. So when we looked at arithmetic series, we said because we were always adding and subtracting a value, we could never come to a actual value that we would land on because we're getting closer to positive infinity or closer to negative infinity. When we have a geometric series, there's two different cases that we would look at for this summation. So this notation, this looks like a giant E. It's an epsilon. That just is a notation mathematically that tells us that we're adding together something. So the summation of the terms of an infinite geometric sequence, meaning that it's going on to infinity, is our infinite geometric series. To determine what the behavior is, we have to look at the common ratio of the sequence that is being generated. Because if it's a number larger than 1, the numbers in our sequence are going to get really, really large, right? It kind of tends to look like an exponential growth pattern. Or if we're multiplying by a fraction, then our numbers are going to get really small. So there's two different scenarios that we're going to look at for this type of series. If the absolute value of the common ratio is greater than or equal to the 1, the series does not have a sum, and we would say that the series diverges. So just like with the arithmetic, those numbers are going to get really big, and if I try to add them, the summation is just going to get really large. So we say that it's going to diverge. So an example would be here that we look at this pattern or this explicit formula. So our common ratio is 2. 2 is greater than 1. If I was finding a series or asked to find the what the summation was, I would say that that one diverges. It's not possible for me to sum those together. The other scenario would be if the absolute value of your common ratio is less than 1. That means that your terms are getting infinitely smaller. And in this case, we're going to say that the series converges. Converges means that the terms are getting so close to the 0 that the change to the summation is negligible. Like it's not even having an impact because that decimal would be so small and close to 0. It's really like adding nothing. So we're going to say it converges to a value. So for this example, the common ratio is 1/3, and so I would look at that and say, yes, that is going to converge, and then that leads us to the question, well, how do I figure out what it converges to? So in order to determine the value that the series converges to, we use the formula a sub 1, the first term, divided by 1 minus the common ratio. Once we calculate that value, that's going to be equal to the summation of that infinite geometric series. So here's just a couple of examples. So for number 1, again, we said this notation means that we're summing together all of these values. This number at the bottom says I'm starting at the first term, and then it tells me that I'm going to infinity. So anytime you see that notation, that's what that means. Again, our focus should be on R. So R in this case is 0.06. It's less than 1. So we would say that this series is going to converge. In order to figure out what that converges to, we take the first term, which is 4, divided by 1 minus R, so 0.6. So 4 divided by 1 minus 0.6 is going to be equal to 10. Okay. For problem number 2, the R value is negative 1/4. So again, that is our common ratio. The absolute value is less than 1. So again, this one is going to be an example where it converges. And then to see where it converges to, we would take the first term, 5 is a sub 1, over 1 minus the negative. So that does end up turning into a positive. So we would have 5 divided by 1.25. And so that series is going to converge to 4. Number 3, the R value is 4, that or negative 4, that's going to be larger than 1. So the only thing we have to say about that series is that it diverges. I cannot find the summation for that one. And then number 4, if you notice, the notation is just a little bit different. It just means that we're calling the first term a sub 0, so I don't have to have that -1. Again, we still focus on the 1/2. So because it is less than 1, it converges to 2 divided by 1 minus 1/2, which is 4. Okay, so that's really the simplest of all of them, I think. Again, so some of the summation notation and learning the lingo, this tells me that I'm adding things together. The index is k, and then equal to 1. It could be n. It's just the variable that they're using to write the explicit formula, so don't let it throw you off if you see different variables there. We're just generating a sequence. The limit or the lower limit is the term number that I'm starting at. So this one's telling me that I'm adding together the first term through the 100th term, and I'm generating the numbers in that sequence by using the rule k to the second power. So you can use that actually for your finite series that we learned about, and then we had the formula for. And we can convert between the two notations, because summation notation is just another way to write this series. And so we do need to know the formula. So if we look at example 1, we have a common difference of 6. I'm adding 6 to each of those terms to generate the next. And I don't know how many terms, because we have this ... here. It just means there's some terms in between there. I just don't know how many. So before we can write that summation notation, we're going to have to figure that out. So we need our formula. So a sub n is equal to the first term, which is -7, plus n minus 1 times the common difference is 6. I know that I have 53. I just don't know what n is. We can plug in and we can solve for n. So if I add 6, I would get 60. I can go ahead and divide that by 6, so that's 10. That's n minus 1. I'm just doing that kind of small there because I'm going to run out of room. So n is equal to 11. So this is the 11th term. So for the summation notation, they're asking us to add together everything from the first term to the 11th term, and we're using the formula -7 plus n minus 1 times 6. So that is the exact same problem. It's just written a different way. Example 2, if we look at this one, we're multiplying by -4, so we have a common ratio. They're telling me here that they only want me to add through to the 9th term. So to write that in summation notation, we're starting at the first term, we're going to the 9th term. The first term is 1, so I don't need to write that in for a sub 1, and we would say -4 to the n minus 1 power. And then also the same thing there for number 3. They don't tell us what the last term is, but they do tell us that they want us to add together 7 of those terms. So the first term again is going to be 1. Common ratio is -5 to the n minus 1 power. So the nice thing here is that we can actually take, and we don't have to use that formula. You can use a calculator to do these problems. I will link in a couple different calculators for you onto Canvas. The one that I do have pulled up on my computer today is the one that is under Math is Fun. And so you see that they have this labeled using n, and our first example had k. So again, the variable really does not matter. You just want to make sure that whatever your calculator is using is the one that you use. If you have a TI-84 at home, you can either hit alpha window and you'll see the summation epsilon there, or if you hit math and go to summation, you'll also see it on that menu. If you don't have a calculator, then again you can use this one that I'll have for you on Canvas. So k is equal to 1 was our first example. We're adding 7 terms. And then the formula that was generating that sequence was 4 to the k. So I'm going to change it to an n here. And I didn't hit my parentheses correctly, so we'll try that one more time. And so you see that they're adding those together, and they're getting 5,461. So that's really all that you're doing. And once you understand that that's what you're doing, then you can have your technology really quickly add that together for you. So for this one, this would be an arithmetic sequence generated by that formula. So if I took and added together the first 35 terms of that sequence, I would get 1,435. So again, using your calculator, using your technology, once you understand the math, is perfectly acceptable.